section 7.4, solve linear systems by multiplying first. So in a linear system like this one, 6x minus 2y equals 1 and negative 2x plus 3y equals negative 5, neither variable can be eliminated by just adding or subtracting the equations. So for systems like these, you're going to multiply one or sometimes both equations by a constant so that when you add or subtract the equations, you can eliminate a variable. So in this system, if we multiply this whole equation by 3, our top equation stays the same, but then my bottom one becomes negative 6x plus 9y equals negative 15. Now I can add these together and eliminate x, and my new system is equivalent to the original system I started with. So we're going to start in our first example by multiplying one equation and then adding to solve our linear system. So if you notice here, if I multiply this equation by a negative 2, I'll be able to eliminate my x's, because 2 times negative 2 is negative 4, and then I can add them together. So I'm going to multiply that whole equation by negative 2. I'm just going to rewrite it underneath. So I have negative 4x minus 2y equals a positive 18, because negative 2 times negative 9 is 18. So when I add them together, those cancel. 11y plus a negative 2y is 9y. And then 9 plus 18 is 27. And I'm going to divide both sides by 9 to solve for y. And I get y equals 3. Now that I know what y is, I'm going to go back into one of my two original equations before I multiplied anything and solve it for x. So I'm going to pick this one here. It won't matter which one you pick. So 2x plus y, which is 3, equals negative 9. I'm going to subtract 3 from both sides. 2x equals negative 12. And then I'm going to divide both sides by 2 to get x equals negative 6. So my solution is negative 6, 3. And then you can go back with the negative 6, 3 and plug it into both equations for x and y and make sure that you get the right answer. So if I put in negative 6 and 3 here, I should get negative 9. If I put in negative 6 here and 3 here, I should get positive 9. If you don't get that, then you know you did it wrong. To eliminate one variable when adding or subtracting equations in a linear system, you may need to multiply both equations by constants. Use the least common multiple of the coefficients of one of the variables to determine the constants. Okay, so first thing we're going to do here is put them in the same form. So I'm going to add this 7x to both sides. So I have x, y constant. So rewriting this, I have 2x minus 3y equals 6. And 7x plus 4y equals negative 8. So I can choose to eliminate x or I can choose to eliminate y. I'm going to choose y because they're already opposite sides. So in order to eliminate them, you can either just multiply them by each other, or if there's a smaller number that they both go into, you can use that. There isn't a smaller number here, so I'm going to multiply the top equation by 4 and the bottom equation by 3. The least common multiple of 3 and 4 is 12. So I'm going to distribute those. So 4 times 2x is 8x. 4 times negative 3y is minus 12y. 4 times 6 is 24. Then I'm going to distribute the 3 on this equation. 3 times 7x is 21x. 3 times 4y is 12y. 3 times negative 8 is negative 24. Now I'm going to add the equations together. These will cancel. 21 plus 8 is 29. X. 24 minus 24 is 0. I'm going to divide both sides by 29, and I get x equals 0. So now I can go back into either one of these originals to solve it for y. This one's already kind of solved for y. I just have to divide it. So I'm going to use that one. So 4y equals negative 7, x is 0. So I plugged it in there, and then minus 8. So 4y equals negative 7 times 0 is 0, so it's gone. Negative 8. And then I divide both sides by 4 to solve this for y. So my ordered pair is 0, negative 2. And again, you can take 0, negative 2, put it into both of these original equations for x and y, and make sure that they both equal what they're supposed to. Okay, Mr. Alvarado bought a total of 20 pounds of grass seed at the nursery for $168. He paid $9 per pound for Kentucky bluegrass and $6 per pound for tall fescue. Which system of equations can be used to find the amount x in pounds of Kentucky bluegrass and the amount y in pounds of tall fescue Mr. Alvarado purchased? So we know he bought a total of 20 pounds. So we know that x plus y has to equal 20. That's our first equation. So looking at the answer choices, we already know that A and C can be eliminated because A and C don't have x plus y equals 20. The second equation we're always going to do here is our cost. His total price that he paid was $168. He paid $9 per pound for Kentucky bluegrass, which is x. So $9 per pound of Kentucky bluegrass plus $6 per pound of tall fescue. So that is choice D. So methods for solving linear systems, you have your table methods. When the x values are integers, so that equal values can be seen in the table. So you would look at like a graphic calculator, or you could just make a table. You just want to pick x integers for x values to see. And then you're just looking to see when you get the same thing for both equations and y when you put an x value in. You can graph. You're looking for when the lines intersect. You can use substitution. When one equation is already solved for x or y, like if we have x equals 20 minus y, it's already solved for x. So it's easy to substitute it into another equation. We can use the addition method, which is your elimination method. And that is when the coefficients of one variable are opposites. So if we have 3x plus 2y equals 12 and negative 3x plus 7y equals 18. Now you can easily eliminate by adding them together. You can use a subtraction method when the coefficients of one variable are the same. So if that was a positive 3x, you can subtract the second equation from the first. And then multiplication is when no corresponding coefficients are the same or opposites. You have to multiply one or both equations to make them that way, which is what we did in this section.